Have you ever stopped to wonder how our wireless world actually works? I mean, how do billions of devices all talk at once without everything just dissolving into chaos? Well, today we're going to pull back the curtain on one of the cleverest tricks in the book, the simple idea of dividing space. Just think about it for a second. You've got billions of phones, laptops, smartwatches, you name it, all competing for the same limited resource, the airwaves. It's kind of like being in a giant packed room where everyone is trying to shout over each other at the exact same time. Without a really smart system in place, it would just be a wall of noise. So how do we bring any order to all that chaos? Well, for a long time, the approach was basically a megaphone. The cell tower would just blast its signal out in every single direction, hoping to hit its target. Now, you can probably guess, this is super inefficient. It wastes a ton of power and creates a whole lot of interference for everybody else. But what if, instead of shouting with a megaphone, the tower could lean in and whisper directly to your device? Now that is a smarter way, a focused, direct signal that saves power and makes sure the message is crystal clear.
And this whole whispering idea, well, it has a name. It represents a huge shift from just broadcasting everywhere to using precision beams. It's called SDMA, and it's a spatial solution to what is a very crowded problem.
So what exactly is Space Division Multiple Access, or SDMA? The secret is right there in the name, space division. At its heart, it's a method that lets us reuse the exact same cell phone frequencies, which are a really scarce resource by the way, by separating users based on their actual physical location. So instead of chopping up time or frequency, we're literally carving up space itself. Okay, so how does that even work, right? How do you actually give someone their own little slice of space in the airwaves? Well, this is where the magic of smart antennas and these focused beams really comes into play. All right, here's the cool part. You've got a base station with what's called an adaptive or smart antenna. Now, this thing doesn't just send a signal out everywhere. Nope. Instead, it creates and steers multiple, really narrow spot beams. A good way to think about it is that each beam is like a dedicated spotlight, pointing directly at one specific user's device. And that's how you can serve a bunch of different people in the same area on the exact same frequency without them ever bumping into each other.
And that leads us to the core principle, which is put perfectly right here. By pointing these individual beams at different spots, the users are separated purely by their physical position. They're separated in what we call the space domain.
The big takeaway here, the really powerful outcome, is that because every user gets their own personal spotlight of signal, they don't have to wait in line or switch channels. It allows for totally simultaneous communication for multiple people, which, as you can imagine, dramatically boosts the entire network's efficiency and its capacity.
So this clever spatial trick sounds great in theory, but what are the real-world benefits? What's the big payoff? Well, this is where you can really see why SDMA is such a game changer.
The advantages are pretty huge. First off, focusing the signal means you get much better transmission quality with way less interference. This improves something called spatial efficiency, which is just a fancy way of saying you get more performance out of the same physical area and can massively increase a cell's capacity. And hey, remember our whisper analogy? By not wasting energy shouting, it seriously cuts down on power consumption, both for the tower and for your phone's battery. And as a nice little bonus, directing radio energy only where it's needed helps address some of those broader health and safety concerns.
And listen, this isn't some far-off futuristic technology. SMDMA is a cornerstone of the wireless systems you and I use every single day. It's absolutely essential for mobile communication, from 4G to 5G. It's used in satellites to beam signals down to different regions on the ground. It's the technology behind all those advanced beam-forming and sectored antennas you see on cell towers everywhere. Now, it's important to know that SDMA isn't the only game in town when it comes to managing the airwaves. To really appreciate what makes it so special, we gotta see how it stacks up against the other major methods out there. Okay, let's try to break this down. As we know, SDMA carves up space. The other methods use totally different approaches. You've got TDMA, which is time division. Think of that like a conversation where everyone agrees to take turns speaking in very specific time slots. Then there's FDMA, or frequency division, which is like giving everyone their own private radio station on a different frequency. And then you have CDMA, or code division. That's more like everyone speaking at once, but in a different language, so your receiver can just filter out and listen to the one language it understands. They all have their pros and cons, but the key thing about SDMA is that its approach is fundamentally different. It doesn't slice up the signal itself, it slices up the physical world the signal is traveling through.
And that really brings us to the bottom line. The absolute genius of SDMA is its elegance and its simplicity. By focusing on where a signal goes, it allows us to reuse the same frequencies over and over and over again, which directly translates to a massive boost in network capacity. It's an incredibly powerful way to make our very finite airwaves feel almost infinite.
Which, of course, leaves us with one big question to chew on. As we demand more and more from our wireless networks, for the Internet of Things, for AR and VR, for all the technologies we haven't even dreamed up yet, this ability to intelligently divide physical space is only going to get more important. So, is this spatial solution the ultimate key to unlocking our hyper-connected future? It's something to think about. Thanks for joining me.